So for question number 2, I did, oh my goodness, just got rid of it. Question number 2, I'm going to explain A and B. So the first one, I just decided to make the fractions have common numerators. So 27 pieces, each the size of 1/43rd, becomes 702 pieces of size 1118, and 26 pieces size 1/45th becomes 207 pieces of size 1215. And so now we know, or now we have two fractions where the numerators are the same. So we really can look at the denominators and figure out which fraction is bigger by picking the one that is the smaller number. So the one with the smaller number means that the whole is divided into less chunks, which means that the chunk sizes are going to be bigger because there's less of them that make up the whole amount. So what I mean by that is, if you have a candy bar and you split it into 2 pieces, or if you have a candy bar and you split it into 3 pieces, the pieces that are split into 2s are going to be the bigger pieces, even though 2 is smaller than 3, because there's less pieces, but the pieces are bigger. So I took that information and I looked at the numbers, and 1118 was smaller than 1215. And so I knew that the fraction 27 pieces of size, each of size 1/43rd, was the bigger fraction. For part B, I did a different method with this. I looked at benchmark fractions. So 13 was pretty close to half of 25, but it was less than half. I just messed that up. It was greater than half because half is 12.5 and it's 0.5 bigger, so it is, I think I just said that wrong again. 13 is greater than half of 25. 13 is greater than half of 25. Okay. So it's greater than 1/2 of 25. And then 34 is almost half of 70, but it's less than 1/2 of 70. So knowing that, I know that the one that is greater than 1/2 has to be bigger than the other one that is smaller than 1/2. So I wrote the one that is smaller first, 34 over 70, because it's less than 1/2. And then I wrote a less than sign, and then I wrote 13 over 25 because 13 over 25 is greater than 1/2.